Review of this chapter and also a little review for the next chapter, which is a really important one, which will be starting in week 7, I guess. So first is factorizing. You want to do it properly. Now, these two you can't do using the methods I did in the class. Now, the first one, the s squared plus 9s minus 65, what you can do is you can find the roots, and then there's a little theorem that says that if k is a root, then s minus k is a factor. Now, in this chapter, you wouldn't bother factorizing c. If you can't factorize it easily, don't bother. You're really just practicing factorizing for chapter 3. But in chapter 3, if you have to factor, and what if my method doesn't work? Well, what you do is use the minus b formula, and then the roots of the that you get, the two answers here, the minus 9 plus the minus square root of 341 over 2, they each give factors. So you get s minus, say the first one, minus 9 plus square root of 341 over 2, and then the other one would be s minus 9 minus square root of 341 over 2. And if you multiply in the minus, so you get this minus minus, in both cases gets your plus 9, and then the minus plus gives you the minus, and the minus minus gives you the plus. So you can factorize it. Now the third one, you can't factorize it using the real numbers at all because you've complex roots. So because you've no real roots, there's no real factors. So here in C dashed, you've got real roots, so you have real factors. But if the b squared minus 4ac is negative, you've complex roots, so only complex factors. And this is stuff you'll have to understand. So you need to know that a negative exponential goes to 0, and the larger this number here is, the faster it goes to 0. This one also goes to 0. Basically what happens is, while t gets really, really big, when I say goes to 0, I mean in both cases, as t gets big. Now here you get t gets really, really big, but the negative exponential goes to 0 faster, essentially. So you're essentially multiplying a big by a very small, and it goes to 0. Now, the way you want to think about it really is you're comparing t is big and e to the 8t is very big. And so t, this is probably down below, over e to the 8t, big divided by very, very big is small. But of course, dividing by an exponential is a negative exponential. So t e to the minus 8t goes to 0. That's probably explained down here, yeah. As t gets big, e 8 to t is way, way, way bigger than t. That's why. Oh yeah, it's just explained down there again, yeah. And then the third one, both of the terms go to 0 separately. Which one goes faster? So this one goes to 0 faster. So we mentioned this above, the multiple of t says how fast it goes to 0. Now they have to be negative exponentials. And then what's going on here is you have a wave, but multiplied by something going to 0. So it'll be like a wave where the oscillations are getting smaller and smaller and smaller. So yeah, so it does go to 0, but you get these out. This isn't the best picture. We could have a better picture here. Better picture is oscillations that decrease. Now actually the way I've drawn it, like you see the width of these, they shouldn't change. I'm making them narrower. That's not quite correct. Even though it's probably what happens in the real world. So here's your big thing. Now, if you want to revise this chapter, I've got an online tool. I don't know whether you have time for that. That's up to you. So this is what it says. First, you solve the homogeneous system by solving the auxiliary equation. Then you find the general solution. Then you add them together, and then you do the initial conditions. So this chapter that we did is very, very tough. No doubt about it. It's only worth 15%. But the hope is that you're kind of building up a lot of understanding for chapter 3, which is coming, and coming fast.